In this screencast, we're going to learn how we use calculus to calculate the volumes of rotated solids when they have empty space in the middle. So instead of a solid disk, we're going to get a washer. And a washer is a disk like that with a hole in the middle. Okay? So every washer has an axis of rotation. So it's going to come through the middle of the washer. There's my axis. And I'm going to have two radii here. I've got the radius of the hole, which we'll call the inside radius, and the radius out to the edge of the washer, which we'll call the outside radius. Okay? So to get the volume of the washer, we're going to take the volume of the whole disk as if it were solid and subtract out the volume of the hole. So a volume of a washer is going to be the volume of the disk, which is pi r out squared, and the thickness here is dy, minus the volume of the hole. That's pi r in squared dy. So I can factor out a pi, and that gives me r out squared minus r in squared dy. So if I wanted to get the volume of the whole thing, it would be pi times the integral from the beginning of my solid, which we'll call A, to the end of my solid, which we'll call B, of r out squared minus r in squared dy. Most common mistake is that students forget that you're supposed to always square the radii before you subtract. Don't forget to square before you subtract. Let's do an example. Okay, so we're going to have the r be the region that is bounded by this exponential here and this square root function between x equals 1 and x equals 4. So our area is this area right in here. We're going to rotate this around the x-axis. So what happens is I'm going to get this situation here. Okay, and can you see that if I rotate this around the x-axis, I'm going to have an open hole right here. And the solid itself is going to look like that. And then there's an open hole in there too. So if I pull out a representative washer, here's my point x comma y. There's my hole. Okay. And can you see that the thickness of this washer is dx? The inside radius goes from the axis of rotation up to the square root function. So Rn is the square root of x. And the outside radius goes from the axis of rotation up to the exponential. So R out is 6e to the negative 0.2x. So now we're ready to figure out the volume of one washer. dV is pi r out squared, that's 36 e to the negative 0.4 x minus the square root of x squared, So that's going to give me x. So it's r in squared, I'm sorry, r out squared minus r in squared times dx. So the volume of the whole thing is going to be pi times the integral from 1 to 4 of 36e to the negative 0.4x minus x dx. Alright, so calculator time. I'm going to go math 9, 36 e to the negative 0.4x, close parentheses, minus x, comma, x, comma, 1, comma, 4, close parentheses. And there's our answer. Let me grab that for you. Don't forget that that is being multiplied by pi. So let me write the pi right there. Okay. Next example. This is the region bounded by x equals 0. That's the y-axis. Y equals 0. That's the x-axis. And y equals 4 minus x squared, this parabola. The trick is we're rotating it around the line x equals 3. So the axis of rotation is not the x-axis or the y-axis. So let me highlight the area we're rotating. And it's going to go like this. And so this right here is a hole. This is the base of the solid part. Okay? And the top of this thing is coming around like this. And so a representative washer will look like this. And then there's the empty space in the middle. Okay? Okay. So, my inside radius. My inside radius is measured from the axis of rotation back to the original area. And you'll notice that that's going to be let's see, 3 minus x. Because from here to here is x. From here out to here is 3. So this piece is 3 minus x. We've got a little bit of a problem. Because what is x? Well, y is equal to 4 minus x squared. So x squared is equal to 4 minus y. So x is equal to the square root of 4 minus y. So that means that our inside radius is 3 minus the square root of 4 minus y. My outside radius is going to go from the axis of rotation all the way out to the edge of my solid, which is going to be a constant of 3. Okay, ready to get the volume of the washer? The volume of the washer is going to be pi r out squared, which is 9, minus r in squared, which is 3 minus the square root of 4 minus y quantity squared dy. Now, we're stacking these things from the bottom to the top. So I'm going to use y values for my limits. The volume of this solid is going to be pi times the integral from 0 to 4 of that integrand we just figured out. I don't know about you, but I definitely wouldn't want to try and do that by hand. I guess we could, but boy, what a mess that would be. Okay, so let's enter it in here. Clear out the old stuff. Math 9. And I've got 9 minus parentheses 3 minus square root 4 minus x. Your calculator doesn't care if you use x or y, so we'll just use x since it's convenient. Squared. Wait a minute, I need another parentheses, don't I? Parentheses, now we square it. Comma, x, comma, 0, comma, 4. And we let it do its work. 24, how about that? I'll capture that. And that is how you do integration using washers.